We often hear that ABA is only used for autistic individuals, and this is actually a myth. ABA is used in many different areas of life, as seen in the previous video. Now we'll take 2 minutes to reflect and make a list of 10 ways in which improving human behavior is beneficial. This can be from your own life, your professional life, or from the life of others. So take 2 minutes to create this list. Here are some examples that I came up with. We can teach a student how to read for the first time, teach an autistic student how to communicate with a speech-generating device, teach a basketball player how to shoot more accurately, improve behavior in community members to better sustain the environment, and improve employee job performance. So as we can see, applied behavior analysis can be applied to so many different areas of life. What is science? Before we talk about exactly what science is, reflect on what science means to you. Take 5 minutes to do this. Reflect on what is science and how does science currently apply to your profession. So science is a systematic approach for seeking and organizing knowledge about the natural world. Science seeks to discover nature's truths. Scientific investigation has 3 parts: description, prediction, and control. Description involves a collection of facts about observed events. It can be quantified, it can be classified, and it can be examined. And this allows for us to create possible hypotheses. Some examples of description include a teacher observes that a student hits their peer when she tells them to share, or you observe that your dog barks when the doorbell rings, or a boss observes that more sales are made when she gives everyone free lunch that day, or a parent observes that their child gives their broccoli to the dog at dinner time. Prediction is repeated observations that identify that 2 things consistently covary, and this involves correlation, which we can predict probability of one event based on the other. Some prediction examples include, after months of playtime, the teacher has observed that the student hits their peer every time she tells them to share. She can predict that in the future, if she tells her to share, she will hit the peer. Another example includes, you've observed multiple times that your dogs jump on people anytime they walk through the door. You can predict that the next time someone comes over, your dogs will jump on them. Lastly, a parent has observed several times that their child asks for ice cream every time they hear the freezer open. They can predict that when they open the freezer next, their child will ask for ice cream. Control is the highest level of scientific understanding, and it demonstrates a functional relationship. And we often like to refer to control as influence rather than control. Some examples of control include, a boss predicted from observations that sales increase when free lunch is given to staff. The boss implements a system to give weekly free lunch and sales increase drastically. Again, we're showing that experimental control. A teacher predicted from observations that when they let the class work in pairs, the class completes their work faster. The teacher implements a plan to add working in pairs every day, and the class increases how quickly they get the work done. Again, we're showing this functional relationship. We mentioned that control includes a functional relationship. So a functional relationship exists when a well-controlled experiment demonstrates that a specific change in one event, the dependent variable, is reliably produced by specific manipulations of another event, the independent variable, and that the change in the dependent variable was unlikely to be the result of other extraneous factors, which are called confounding variables. So there's a lot of jargon words in here, but we'll break it down as we go throughout this. We have our independent variable, which is reliably producing a change in our dependent variable, and we have our confounding variables that are extraneous factors that aren't producing that change. Let's do a quick review. What is the following an example of? You observe multiple times that your dog barks when the doorbell rings. You hypothesize that in the future your dog will bark when the doorbell rings. Is this an example of A, description, B, prediction, C, control, or D, all of the above? You can take some time to think about this or pause the video if you need more time. The answer is, this is an example of prediction. Now it's time for a 10-minute activity. Open ChatGPT and ask for examples of functional relationships that exist in the natural environment. Then take time to come up with your own 5 examples. Next, we will talk about a scientist's behavior. We've talked about what science is, we've talked about description, prediction, and control, and now we'll talk about the behaviors of a scientist. We have determinism, empiricism, experimentation, replication, parsimony, and philosophical doubt, and we'll dive into each of these. Determinism states that the universe is a lawful and orderly place. For example, a student starts screaming. We know that the student screaming is not random and didn't happen accidentally. There are reasons that resulted in the student screaming. In this example, let's say the peer hit a student and the student starts screaming. We see that through determinism, we assume that the universe is a lawful and orderly place and things aren't happening random and accidentally. Empiricism is objective observation and measurement. An example of empiricism is, instead of stating that the student is super disruptive in class, the teacher decides to observe and collect data on how often the student is talking out during a 60-minute lesson. Again, we have objective observation, and this is empiricism, another characteristic of a scientist. Next, we have experimentation, and this is controlling and manipulating factors to identify if there is a functional relationship. So we discussed what a functional relationship is, and experimentation involves controlling and manipulating those factors to identify if a functional relationship exists. For example, a teacher hypothesizes that a student begins to yell when the teacher tells them to start work because they don't want to do their worksheet and they want to keep playing with their toys. The teacher stops telling the student to do their work and the student doesn't yell. The teacher tells the student to work and stop playing and the student begins to yell again. Again, they're manipulating these factors to identify if there's a functional relationship in this context. Replication is repeated experimentation to determine reliability. For example, the teacher repeats the previous example several times to understand that demands to work and stop playing reliably result in yelling. So again, we use replication to reliably understand if there's a functional relationship. Parsimony is choosing the simplest explanation, the one that requires the fewest assumptions. For example, a parent tells the teacher that the student is getting out of their seat because they likely are a part of a school-wide club that has agreed to boycott sitting in their seats. Using the simplest explanation, however, the teacher observes that the student gets out of their seat to talk to their friend across the room. Again, parsimony is using the simplest explanation that requires the least amount of assumptions. Philosophical doubt, my favorite, is continually questioning the truthfulness of what is regarded as fact. For example, a teacher hears about a new method to teach math. Instead of immediately implementing it in her classroom, she compares the method to her current teaching style and compares the results between both methods and the test scores. Let's review. Which of the following is one of the behaviors of a scientist? Philosophical doubt, control, prediction, or description? I'll give you a second to think about that. The answer is A, philosophical doubt. Control, prediction, and description are the parts of scientific investigation. So philosophical doubt is the only behavior of a scientist in these options. Next, we have a 5-minute activity. Reflect on the behaviors of a scientist. How can you use these behaviors in your current profession? Provide 3 examples of how the behaviors of a scientist could impact you and your current practice. Next, we will be talking about the branches of behavior analysis. We have behaviorism, experimental analysis of behavior, and applied behavior analysis. First, let's talk about a little family history. In the early 1900s, psychology primarily studied mental processes. Then Watson came along and wrote psychology as the behaviorist views it. Then we have Skinner's radical behaviorism, which sought to understand all human behavior, private and public behaviors. So here we can kind of see behavior analysis family tree. Behaviorism is the philosophy of the science of behavior. Experimental analysis of behavior is basic research is the province of experimental analysis of behavior. Applied behavior analysis seeks to develop a technology for improving behavior. Now we have the domains of behavior analytics, science, and professional practice. We have behaviorism, experimental analysis of behavior, applied behavior analysis, and professional practice. Here are the domains and their area, goals, activities, and example for each. Radical behaviorism focuses on theory and philosophy. Their goal is to understand the theory of behavior. They engage in activities like conceptual and philosophical analyses. One example of radical behaviorism is Lang's theoretical account of emotions. Experimental analysis of behavior is basic research, and their goal is to discover principles of behavior. They conduct basic experiments, and such example of this is choice making. Applied behavior analysis is focused on applied research, and their goal is to discover how to improve socially significant behaviors. They engage in activities like conducting applied experiments. For example, conducting an experiment on how language develops. Again, this is a socially significant behavior. Practice guided by behavior analysis focuses on helping people improve socially significant behaviors. Their goal is to improve lives by changing behavior. The activities they engage in can include designing, implementing, and evaluating behavior change programs. For example, teaching an autistic kid how to communicate. Translational research is the bridge between experimental analysis of behavior and applied behavior analysis. This is a video you'll watch on translational research and what it is.